Hi there, welcome to 6-3 Part 2. Now, as you probably noticed as you were doing some of these elimination systems, that it kind of worked out nicely that every time you either added or subtracted, your variables would cancel out. Now, obviously, this isn't always going to be true. And when it's not true, in order to use elimination, we may need to multiply one or both of the equations by a number so that we can have opposite coefficients that will in fact cancel out. So this will kind of be the new step one of elimination. So let's take a look at how this works. So here I have x plus 2y equals 11 and negative 3x plus y equals negative 5. Now the first thing that we have to do is we have to decide whether we want to cancel out the x's or the y's, and it doesn't really matter which one I choose. In this case, I'm going to choose to cancel out the x's. Now, in order for the x's to be canceled out, I need this to be a 3. Okay, because 3x and negative 3x would cancel out. So what I'm going to do is I'm going to take and I'm going to multiply this entire equation by 3. Okay, so when I do that, I get 3x plus 6y equals 33. And then I'm just going to recopy this equation just as it was. And now you can see when I add these together, 3 and negative 3 are going to cancel out. 6y plus 1y is 7y. And 33 plus negative 5 is 28. So then I divide by 7, and I figure out that y is 4. And then I can take this and plug it back into, again, one of my original equations. So negative 3x plus 4 equals negative 5. Subtract 4. So we get negative 3x equals negative 9. Divide by negative 3, so x is 3. So my solution is the ordered pair 3, 4. And again, I would want to check this to make sure that it works. And yep, I think it does. So 3, 4. Okay, let's look at another one here. Now this one's a little bit harder. And once again, I have to make the decision, do I want to cancel out the x or cancel out the y? And it doesn't really matter at all. So let's say, since we did the x the last time, let's do the y this time. I have 2y and 3y. Now, I want those to be the same. So I have to think about what do 2 and 3 both go into, and that would be 6, right? They both go into 6. So I want to make one of them positive 6, and one of them negative 6. So in order to do that, let's make the top one negative 6. So let's times by negative 3 there. And when I do that, I'm going to get 15x minus 6y equals negative 96. Now down here, I want this to be a positive 6. So I'm going to times by positive 2. And that's going to give me 4x plus 6y equals 20. And then again, I'm just going to add these two equations together. When I do so, I have 19x. My y's are going to cancel out. And I'm going to get negative 76 here. So I'm going to divide both sides by 19. I believe that negative 76 divided by 19 is negative 4. And then once again, I take that, I plug it back into one of my original equations. So I'd have 2 times negative 4 plus 3y equals 10. It's going to be negative 8 plus 3y equals 10. So I'm going to add 8. So we get 3y equals 18. Divide by 3. y is 6. So we get negative 4, 6. Okay. Once again, I'd want to check real quick to make sure that works. And it looks like it does, so my solution would be negative 4, 6. Alright, now let's look at a story problem. It says Sally spent $14.85 to buy 13 flowers. She bought lilies, which cost $1.25 each, and tulips, which cost 90 cents each. How many of each flower did she buy? Now these are kind of like the story problems we did the other day, where I have to come up with two equations. So let's call lilies x and tulips y. Okay, so I know she bought 13 total flowers. So x plus y equals 13 is going to be our first equation here. Then we want to look at her price. So she spent $14.85, $1.25 each on the lilies, so 1.25 times the lilies, 90 cents on the tulips, so 0.90 y, and that totaled up to $14.85. So that would be our second equation. Now we can use elimination to help us solve this. So let's say we want to cancel out the x's. So let's multiply this by negative 1.25. So when I do that, I will get negative 1.25x minus 1.25y equals negative, and then I got to do 13 times 1.25, and that's 16.25. Okay, and now I can add these together, so I got 0.9 plus negative 1.25, and that's negative 0.35y. And then I have 14.85 plus negative 16.25, and that's negative 1.4. So then, to solve for y, I'm going to divide by negative 0.35. I think that comes out to be 4. So that means she bought 4 tulips, and then I'm going to plug that in back to one of my original equations. So I'd have x plus 4 equals 13, and I'd figure out that she bought 9 lilies. So my answer would be 9 lilies, 4 tulips. Okay, so as you can see, we can use elimination also on story problems. Sometimes it gets a little messy with the decimals and things, but usually works out pretty nice. So that's elimination, where we have to multiply first in order to cancel out variables. As always, let me know if you have any questions, and I'll see you tomorrow.